So this is question 4 from the June 2019 paper 1, Physics. The Wi-Fi wireless fidelity has fast become a very necessary tool for electronic communication, learning and accessing social platforms. Electromagnetic waves are essential in wireless communication. Wi-Fi makes use of low-frequency magnetic waves. Name the type of electromagnetic waves used in Wi-Fi. So remember I said to you, you have to learn that whole spectrum. What are the waves? What are their wavelengths? How do you know what they are? There's actually a clue here. It says low frequency. So then you know that you must look on the low frequency end of the scale for these if you can't remember that table. So in the memo it says these are radio waves. If you Google, there's some crossover with Wi-Fi between radio waves and microwaves. So I would have accepted either answer, radio waves or microwaves, but it had to be a low frequency wave. State one advantage that the type of radiation in 4.1.1 has for the use in Wi-Fi. Why do we like radio waves? They travel a long distance. Okay, so the other waves, the high frequency waves, tend not to travel such a long distance very readily. They tend to be broken up and lose their power. So these radio waves can travel a long distance, which makes them useful for Wi-Fi. A photon associated with a certain electromagnetic wave has 1,46 times 10 to the negative 24 joules of energy. Define the term photon. This is another definition you have to learn. It's a packet of energy found in light. What is the speed at which electromagnetic waves travel? This is 2 marks for absolute free. Okay, you know that all electromagnetic waves travel at the same speed in the medium. That is what is one of the defining characteristics of electromagnetic radiation, and the speed is given to you in this table. Speed of light in a vacuum, because light is an electromagnetic wave. So your answer, you can just get it straight out of the data sheet at the back of the exam paper, and it's 3 times 10 to the 8 meters per second. Okay, make sure that you have the unit, no mark. So it's 3 times 10 to the 8 meters per second, and if you can't remember it in your head, you just read it off the data sheet. Now it says to you, calculate the wavelength of this electromagnetic wave in meters. So we know that the energy of a wave is related to the frequency of the wave. We have that formula E equals HF, where energy equals Planck's constant times the frequency of the wave. They are asking you to find the wavelength of this wave. So that E equals HF has actually got 2 forms. We have E equals HF or E equals HC over lambda. So all you have to do is take this formula, which is relating energy and wavelength, and you put the energy in from the question. Here's the energy stated in the question. H is Planck's constant. This is Planck's constant as given on the data sheet. C is the speed of light, which is we've just given as the answer to the previous question, and that leaves you with lambda as the only unknown in the calculation. And if you can use your calculator and write down the formula, substitute and find your answer, you've got 4 marks very, very easily. Remember, you have to write the formula every single time. There is often 1 mark for the formula, so every single time you write the formula, you copy it off the data sheet. So here is the calculation here. Let me put this calculation where it belongs. So here we write the formula for 1 mark, E equals HC over lambda. Here is this value from the question for the energy. Here is Planck's constant, here is the speed of light and sound, and there is lambda. If you work it out, you get a value of 0,136 meters. Then it says to you, if the wavelength of this electromagnetic wave was doubled, what effect would this have on its penetrating ability? Write only increase, decrease, or remain the same. These questions are here to test your understanding. If you have a formula, you can work it out. The energy is inversely proportional to the wavelength. Look at this formula. Here's my energy. Here's my wavelength. The wavelength is a denominator. So if the energy gets bigger, the wavelength has to get smaller, because remember, you are dividing by the wavelength. So if the wavelength gets bigger, the energy is actually going to decrease, because the wavelength and the energy are inversely proportional. So it says, briefly explain your answer. So this is only 2 marks, so you don't have to write a long explanation, okay? But make sure that you don't put it in your answer. I don't want to see any its. I want you to use all of your words. So for instance, you can say wavelength is inversely proportional to energy. Okay, so we want to first state that we know that. So if the wavelength increases, the energy will decrease. Okay, and then you can also say energy is related, the higher the lower the energy, the less the wave can penetrate. Because remember, it said to you right at the beginning, what effect would this have on its penetrating ability? So we want to talk about the energy and the penetrating ability. So we have to say wavelength is inversely proportional to energy. So when the wavelength gets bigger, the energy gets smaller. But then we have to state, why is the energy important? We need to link our energy to the penetrating ability. So we must link the wavelength to the energy, and then link the energy to the penetrating ability. So that would get you your full 2 marks, stating that with an increase in wavelength, there's a decrease in energy, and as soon as the energy decreases, the penetrating ability also decreases.